Is our search for habitable worlds hiding in plain sight, farther out in our own galaxy than we ever imagined? For years, astronomers have focused their gaze on the Galactic Habitable Zone, GHZ, the region of a galaxy most likely to nurture complex life. But here's where it gets controversial. Recent research suggests that the outer edges of our Milky Way might hold even greater promise than previously thought. A dynamic team of scientists from around the globe has shaken up our understanding by exploring the effects of stellar migration. That is, the movement of stars across the galaxy on the chances of finding habitable planets. Using advanced computer simulations, they modeled how stars drifting from one region to another might reshape the GHZ and affect the formation of rocky, Earth-like worlds. To dig deeper, the team didn't just consider stellar migration. They built chemical evolution models that track the changes in our galaxy's composition, especially its thickness and abundance of life-building elements. Their aim? To statistically analyze where and how frequently habitable terrestrial planets could be born around different types of stars. And this is the part most people miss. The movement of stars through the galaxy doesn't just scatter them randomly. It actually increases the odds of finding habitable planets in the outer reaches of the Milky Way. The researchers calculated that stellar migration could make stars 5 times more likely to host terrestrial worlds compared to if they'd stayed put. That's a huge leap. The study also found another twist. Gigantic planets, like our Jupiter, might play a big role in shaping the destiny of smaller, rocky planets in the galaxy's inner regions. The authors highlight their work as a major extension of GHZ research, expanding the parameters far beyond what earlier studies considered. As new space missions begin to explore exoplanet diversity more deeply, like ESA's PLATO project aiming to examine 1 million stars via transit observations, the Ariel mission focused on dissecting the chemistry and heat profiles of at least 1,000 known exoplanets. And the ambitious LIFE initiative, which studies the atmospheres of rocky worlds for life-indicating biomarkers. The results from this study are set to influence future discoveries in profound ways. But here's where opinions can really diverge. The core concept of the GHZ dates back decades, evolving from the simpler stellar habitable zone, the area around a star where liquid water is possible, into a galactic-level perspective with much more complexity. The precise boundaries of the GHZ are still debated. Many astronomers agree it doesn't exist near the heart of the galaxy, where exploding stars and cosmic chaos would overwhelm any chance for life to flourish. Yet, as we continue learning, could our assumptions about where life may exist prove wrong? As ESA gets ready to launch missions like PLATO in 2026 and Ariel in 2029, our picture of potential life-bearing worlds may transform dramatically. PLATO will use the transit method, proven to reveal thousands of exoplanets, while Ariel will probe the atmospheres and heat signatures of these distant worlds, asking questions about their chemistry and potential habitability. Life, since 2017, has been working to spot the biochemical fingerprints that might reveal living processes far from Earth. So what surprises could lie ahead regarding the GHZ and how wandering stars shape the fate of life in our galaxy? Is the future of astrobiology hiding not closer to home, but out in the galactic suburbs? Only time and spirited scientific debate will reveal the answers. Let's hear your thoughts. Do you agree with the idea that the outer galaxy could be humanity's next great frontier in the search for life? Or do you think the classic assumptions about the GHZ will stand the test of time? Could the presence of giant planets hinder or help the hunt for habitable worlds nearby? Share your perspective below, and keep watching the stars. Science is just getting started.